This question is taken from the NSAA 2020 Section 1 paper, and it is question 36 of the Physics subsection. P and Q are fixed point 6 meters apart on the ocean surface. A wave of frequency 0.5 Hz travels at constant speed from P to Q. A peak passes Q at t equals 0 seconds. The next wave peak travelling towards Q passes P at time t equals 0.8 seconds. So this peak that is the next one to reach Q will firstly hit P at t equals 0.8 seconds. So what is the speed of the wave? So it'd be good to draw the setup of what is happening here. So at t equals 0 seconds we have this wave, and then we have another peak which has not yet even reached P. So at t equals 0.8 seconds it will have moved so that it has reached P. So wherever it may have been beforehand. So how is any of this information useful in calculating the speed of the wave? So how could we calculate speed of the wave? Well, what equations do we know from school that are useful? So speed of the wave is wavelength times frequency. We have frequency, so we need to work out the wavelength. The information doesn't seem very obvious as how we could work out this wavelength. But what do we know, especially about these peaks? So we could look at the distances travelled by these peaks. So we know that one wavelength is this distance between where the peak was and Q. So where it was before at t equals 0 and then Q. So one wavelength must be the distance 0.8 v, the distance it took to get to P, and then add the 6 meters to get to Q, because we know they're 6 meters apart. So this must have been one wavelength. And then we know the wavelength is the speed of the wave divided by frequency. So dividing by 0.5 or a half will just give us 2v. So if we put this in, we know that 0.8v plus 6, which is the total wavelength, or the total distance travelled in this period, is 2v, using that relationship that we found above. So that must mean that 1.2v equals 6, and then the wave speed we can simply see is 5 meters per second. So if you wanted to rephrase this, you could have seen this as 12v equals 60, so v equals 5. So the speed of the wave is 5 meters per second. So this question was kind of hard in how do we use the information given, because it didn't directly give us the wavelength. But we knew that the distance it travelled, the 0.8 v, so time times the velocity, is that little distance here, plus the 6 meters, gave us our wavelength. So if you wanted to work out the wavelength as just an extra part, then we know the wavelength is 5 divided by, well, f, so 5 times 2, so the wavelength is 10 meters. So this distance is 6 meters, and then there's a 4 meter gap from P to the other wave peak.